Hi everybody, Professor Rad here, and today we're going to evaluate expressions to help us complete a formula. So let's get started. So this example says that the serving size in grams can be used to find a rough estimate of the number of calories in a sandwich at McDonald's by using this formula, where S is the serving size and C is the number of calories. Okay, before I move on and do the action request here, I'm gonna make sure I understand the information being presented to me. So I'm gonna do a little bit of highlighting, I think. So when I read through, there were two things that jumped out at me. We're looking at serving size and we're looking at number of calories. So let's highlight that. We've got our serving size, which is being measured in grams. And we're using that to find a rough estimate in the number of calories. And we're doing this at a sandwich from McDonald's. And then here's my formula. And then they said S is the serving size, so that's green. And then C is the number of calories, so that's yellow. So I'm trying to keep like things together in the same color, so that way when I'm looking for it later on, like I know it's easier for me to see and identify what means what, right? So that formula is jumping out at me in pink, and then serving size I know is S and it's measured in grams, and then C is calories and it's measured in calories. All right, so then it says to complete the table below to approximate the calories in a McDonald's sandwich with each of the provided serving sizes. So S is the serving size, so I'm going to write that above this column, and C is the number of calories. I'm going to write that there, and I'm going to write my formula underneath just so I have it handy when I need it. So 2.8S minus 47. Okay. Cool. So in this situation, they're giving us three different values for S that we're going to substitute into the equation. And then we're going to put our answer, because we're going to get C out of it, we're going to put our answer for C into this column here. So I'm going to start out with this S value of 150. So I'm going to put a little note to myself that this is for S equaling 150. And then I'm going to substitute in wherever I see S, I'm going to replace it with its number, the 150. So C is 2.8S. Now remember, when you have a number directly in front of the variable, that means you've got multiplication. So I'm going to multiply by 150 and then minus 47. And then I can throw this into my calculator. So 2.8 times 150 minus 47, and we're getting 373. So since I used the S value of 150 grams, I'm going to put the answer of 373 in the box next to it. And C is being measured as the number of calories. So I'm going to abbreviate calories with cal just because I can't fit the whole word in the box. All right, and that's it. We're just going to repeat this 2 more times, once using 205 and another time using 240. So let's do S equals 205. That's our next one. So our formula is C equals 2.8S minus 47. So 2.8 times S, which is 205. Minus 47. Throw that in the calculator. And I get 527. So I'm going to take my answer and put it next to 205 in the table. And I'm going to label it cal. Okay, and just a reminder, however you choose to notate your multiplication is up to you. So in the first one, I used the cross, and in the second one, I used the parentheses. In reality, I use both pretty interchangeably, so it's just what my subconscious is choosing at the moment, I guess. So you do you. If you prefer the cross or the dot, you can do that. If you like using the parentheses, you can as well. We don't have any negatives that we're substituting in here, but if I did have negatives, I would absolutely want to use those parentheses. So if you have just positive numbers you're plugging in, you can use whatever form you like. All right, let's do one more together. So the last serving size is 240. So C equals 2.8S, so 2.8 times 240, and then minus 47. 2.8 times 240 minus 47, and we get 625. So I'm going to take that number and plug it into this last box and label it with calories. And there we go. Now, I will also point out that the reason I'm doing this off on the side is so that later on, if I'm checking my work or if the teacher grades it and I get one of these wrong, I can see where I got my answer from. So maybe I made a mistake and I put 502 instead of 205 into the formula, for example. So making sure that your work is organized and clearly labeled can really help you check your work, and also helps your teacher to check your work and know how you're working through the question. The other thing I want to point out is when we're evaluating this formula, the purpose of me writing down this thing, I mean, I'm typing it into my calculator, and I guess I could jump there right away, but the purpose of me writing it down is so that future me knows how I got these answers. So I know where I put each of these numbers into the equation, and it also helps my teacher know that my thinking as well. So sometimes in math, the purpose of showing work is to work out the question, right? It's a self-serving purpose. Like if we're doing long division, we got to write it out to know what we're doing. In a situation like this, especially once you become very familiar with it, the writing it out becomes less to work it out, and the writing it out becomes more to communicate your thoughts and your process. So that's one of the reasons I think teachers are, this is me too, such a stickler for students writing work, because it helps for you to communicate to us your process as you are working through. All right, so I've got a now you try question here. This one is from like a physics type of question using Hooke's law to evaluate this formula and input the results into this table. In the next video, we are going to wrap up evaluating expressions with some very mathy types of examples. Examples you might see more in an algebra course than in, say, like a statistics class. So looking forward to seeing you then. And in the meantime, have a fantastic day.